last time. Honestly, I kind of screwed things up a little. I uh, I tried to do this equation, didn't quite work out, but um, I've kind of come to the decision that yeah, I think I'm just gonna try and relax, and I think I'm just gonna try and stick with this streaming thing. I don't think I'm ready for videos quite yet, so yeah. Now, I'm gonna try and redo streams part one and part two. I mean, part two and part three, just a little, probably just part three, honestly. And what I'm gonna try and do is, let me think. What am I? What I want to do is go through the physics again. And last time I ended up accidentally using the mathematical trick that I used to solve the 2D version to solve the one-dimensional version as well, which is fine at all. But I kind of was very long-winded about it, and I did with paint, and I don't think it ended. I don't know. It was kind of a bit all over the place. So I thought, let's try and do it again using latex. And I've got a nice big font, so you guys should be able to read everything that I write pretty quickly. So yeah, and the other thing is I used kind of physics insights with impulse last time to try and solve the equation. I'm 90% pretty sure you can solve it without physics insights, just purely mathematically. But I'm not really sure how. What I do know is if you go on Wolfram Alpha, right, and you type in the equations and you tell it to solve. So here I'm using the A1, A2, B1, B2, which let's just say there's two masses, right? Then then A1 is the initial velocity of mass 1 and A2 is the final velocity of mass 1. And then same for B and B2, B1 and B2, but that's for mass 2. And if you tell it to solve for A2 and B2, you can see that it does give you those standard solutions of A2 equals, wait, what? No, that's not right. Anyway, it does give you some of the solution. It gives you a bunch of different solutions. Some of them are, I don't know, but some of these require negative mass and stuff, or I mean, this one would, right, or zero mass or whatever. But anyway, the important ones are these ones and these ones, right? This one is this, the A1 equals A2, B1 equals B2, the no change solution, pretty obvious. But then obviously you've got this one, and this is the solution we're after, the one that actually does the collision. Now the problem is Wolfram Alpha won't actually tell me how it came up with that. It doesn't even show it as an option. So I think even if I paid for Wolfram Alpha, like the pro version, I don't think it would necessarily tell me how to solve this. I do have an idea. I could, ask one of those large language thingamabobblies, but I don't know if that would be a good idea or not. So we'll try that later, maybe, if I'm comfortable doing that on stream. But anyway, so for the time being, I'm just going to try and solve it myself. I'll try and do it via substitution. If that doesn't work, I'll try and do it by I'll just do it by the way I figured out last time, and then we can move on to doing it in 2D. There's also a bunch of things I need to do with the actual code itself. I need to make this code more reminiscent of my original code that I did in my own time, or not for stream, because that code allowed the balls to be that allowed you to directly code the position of each ball and stuff. So that's good. That's important too. So yeah, a lot of stuff I need to get through. Lots of so we're just gonna have to do it step by step. It is a bit long-winded, and yes, technically I don't have to do a bunch of this stuff, and it is a little sort of unprofessional because you're I know because you might be thinking James, haven't you done this before, etc., etc. Yeah, I have done this before, but here's the thing: I do really want to try. I want to try and get these things done I haven't figured out a good way to like plan it all out, so I'm just gonna have to do it step by step. And I know it's a bit unprofessional, a bit more off the cuff, but the thing is, this is a live stream, and in the long run, I'm going to be doing projects that I haven't done before, right? Most of these I've sort of run through in my head, but a lot of them, and I've done for a lot of these first ones that I'm going to try and do, I've done them before, or I've done something similar to them before, so I shouldn't hit too many roadblocks. But there are a bunch of them that I haven't actually done before. And, so in the long run, when we're doing the streaming, it's going to be more often than not, not necessarily, completely pre planned, etc. Right? Um, just a second. All right. One other thing is that, honestly, I don't remember. Do you just want to get straight into the physics? We'll go straight into the physics. Oh, someone has joined. Maybe they'll chat. Maybe they won't. I'll keep my eye on the little chat window just in case they stick around. So, anyway, what I was gonna say is, yeah, if I were to do this again, obviously it would have been nice to not have the part 2 and part 3, which were basically just me messing around. I mean, not really. I was trying to explain something, but you know, uh, it would have been nice to have a part 2 and a part 3 that weren't just me messing around in paint for so long and not really getting anywhere. But that's the deal. That's the deal when it comes to live streaming. And I did consider doing it again. I did consider doing a video series, but I think for the time being, I don't really know. There's just so many options with video editing and stuff. And how do I want to do it? How do I want to record myself doing a project? Do I want to just record myself in front of a whiteboard and then skip to me just recording the project off the cuff? Or do I want to pre-plan and sort of like talk over myself? Or do I want to have pre-scripted bits that I do that I record at the laptop doing the programming? There's so many things to figure out, and I just like whatever's, man. Doesn't matter. We'll just it's just like I'm like, it's just too much for me. Too much decision fatigue. For the moment, just relax, just relax. Try and focus on doing the live streaming, getting through a bunch of projects. I have so many projects on the back burner that I've had in my mind for years. Some of them maybe 8 to 10 years. It's been a long time. I've spent so long, too long, but we're going to try and get them done. We're going to try and go through them. So, with that out of the way, let's try and get the physics behind this done. We got. I will use paint for the explanation, just a little at least. Um, oh my gosh, paint's not loading. Don't tell me my computer's going to freeze up on me because I tried to open up paint. I don't need that in my life. What the heck? Why is paint not working? If paint doesn't work, we'll just do the code cogs. Okay, no, paint is working. It's the it was just not showing me the just not showing me the top for some reason. Now it is. Weird. Alrighty. Well, anyway, let's get started. So, same physics problem as before. We're starting simple with a one-dimensional collision. And with one-dimensional collision, you have, let's say this is the x direction, and you have two balls, and they initially are heading presumably towards each other, although algebraically, it really doesn't matter. They each have a mass and a velocity, which we will call mass 1 and velocity 1. So this will be mass 1, and this will be mass 2. Mass 1 will travel with velocity 1, and mass 2 will travel with velocity 2. After the collision, they will have the same mass but different velocities. So we will actually label the initial velocity as velocity 1i, and the initial velocity of the second one as velocity 2i. Okay, cool. Now, in order to For a complete elastic collision, we want no energy loss and no momentum loss, obviously. Now, in an inelastic collision, they can stick to, in a fully inelastic collision, the two objects would stick together and become one mass, and they would have some combined new velocity. And in this case, there would actually be some energy loss to heat or sound or some such scenario that is not modeled by our equation here, that is not modeled in this situation. So it's not that the energy is like being destroyed or going away. It's just that for our calculations, we're only really looking at the kinetic energy of the two balls. And so for our purposes, we can say that it was not an efficient transfer of energy, Whereas in a perfectly elastic collision, then energy is going to be completely conserved in the system, including energy is going to be completely conserved between the original set of kinetic energies and the final set. So there's going to be no difference. So basically, we have our two equations that kinetic energy one that the initial kinetic energy is equal to the final kinetic energy. And also the same for the momentum. Momentum initial equals momentum final. Now, importantly, what we're going to do is we're going to write these equations in LaTeX, so we don't have to worry about PowerPoint too much anymore. So let's do this. So we want our initial kinetic energy. How do I do this? Initial, so you do it? All right. Initial kinetic energy equals final kinetic energy. Right? And we also want initial momentum. No, that's not right. Momentum initial equals momentum final. Now, instead of just writing, oh my gosh, and I also need a new line. Forget about that. Is it / new line? Okay. Why isn't it centered? Why is only the original line centered? That doesn't make any sense. That's annoying. Anyway, so these are the two equations that we want to combine together in order to solve our equation. Now, the first thing I'm going to do is actually change the order of these equations, right? And the second thing is I'm going to actually write them out and expand them properly, okay? So, first things first is we want to, instead of talking about P initial and P final, we're going to say our momentum 1I, our initial momentum of object 1, plus our initial momentum of object 2, which we're going to say P2I, is going to be equal to our final momentum of object 1 plus the final momentum of object 2. And remember that by momentum we mean the mass times the velocity, right? So by momentum, but we really mean, so P1 equals M1. So P1I equals M1 V1I. Gosh, V1I. I have caps lock on for some reason. Why is this so finicky? I hate it. I hate it. It's better than paint. It's better than paint. It's still quite finicky. So P1 is M1 P1I. When I say P1I, I actually mean M1 V1I, etc. Actually, I'll tell you what I'll do. If we're going to go through this, we're going to do it properly. We're going to start with the full equations and then simplify, right? So M1 V1I plus m2 v2I plus is equal to m1 v1f plus m2 v2f. All right, that is our initial momentum equation. You have more closed brackets than open brackets. Where? Oh, there. Okay. That is too big, but that's why so this is our original momentum equation. Mass 1, right? This is our original equation. Wait, does this work? I'm going to copy and paste this. I don't know if it's working or not. Invalid equation. That'll do it. That'll do it. Okay, there we go. Okay, this is our initial momentum equation, right? M1 V1I plus M2 V2I equals M1 V1F plus M1 V2F. We are going to make the substitution that P equals MV, right? By doing, and we'll do this for all of them. So we'll say, for example, P1 equals M1, etc. P1I, for example, will be equal to M1 V1I. Same for all of those, right? So we're going to do that substitution. We'll go back to the other equation in a second. No, what am I doing? I need to start again. I'm going too fast. I'm going too fast. I need to slow down. I need to slow down. All right. Let's just set up the two equations, the momentum and the kinetic energy. So this is the momentum equation, and this is the kinetic energy equation. The kinetic energy equation will be quite similar. Let's just lower the size for a bit, except that these will be squared, right? Because it's mv squared for kinetic energy, and they will all be fractional as well. They will all be divided by 2. Frac. Does that work? Yeah, it does. And same for the other side. Right? Now, I'm going to cut right to the chase. No, I'll do it. I'll do it properly. I'll do it properly. I don't want to, but it's a bit annoying, but I'll do it properly. Frac. There we go. All right. There we go. These are our two equations. Actually, we can break it up even further if we want to be super proper about it. 2 plus frac. There we go. That's what I'm talking about. That's what I'm talking about. Good latex formatting. Awesome. The best. There we go. This is our equation. These are our two equations. Mass 1 times initial velocity 1 plus mass 2 times initial velocity 2, the initial momentum of the system, is equal to the final momentum of the system. And the initial kinetic energy is equal to the final kinetic energy. And actually, it's probably a good thing that I wrote in these 2's because, oh, well, actually, we're going to get rid of them and re-add them, but that's beside the point. All right. The point is, this is our original set of equations. Next, what we can do is multiply both sides of the bottom equation by 2. So that's what we'll do. We'll get rid of these 2's for the time being, which is a bit silly because I just added them, but it's how it is. Okay, I can't actually do it like that, so I guess I'm just gonna have to get rid of the fraction thing. There we go. No more fractions. Okay. So first things first, we'll multiply both sides by 2. So now we have m1 v1 squared, etc. The next thing we want to do is replace m and v by mass and velocity with, we want to replace velocity with momentum. So we're going to make the substitution that P equals mv, and thus that also means that m is equal to, that v is equal to m divided by p. Right? So we're going to make this substitution. So we're going to replace v1i with p1i squared divided by m1. And we're going to, sorry, what did I say? No, with p, we're going to make this substitution. This is just as scuffed as last time. Honestly, this isn't any better. But you know what? We're doing it. We're doing it, and it'll be fine, and it'll be fun. I should have just gone with my gut. I should have just done the initial way and just written it as P from the beginning, but with momentum from the beginning, but whatevers. We're going to replace all of these velocities with momentum divided by mass. So V1I is going to become P1I divided by M1, or initial velocity 1 is going to become initial momentum 1 divided by mass 1. And same for all of these. They're going to be replaced with the correct mass and the correct momentum, right? So all of this M1 V1I is going to become P1I. All of this M2 V2I is going to become P2I. M1 V1F is going to become P2F, and M1 V2F is going to become P2F. Oh, sorry, P1F, P2F, right? So that's the equation we had originally. Now, for kinetic energy is where it gets a bit more interesting. The velocity is actually going to become, the velocities are squared, so they're going to become momentum squared. And so only one of these masses can actually combine with the velocity to become momentum, right? So if we did this substitution here, we would really just get like PV, right? We don't want PV. We want it all in terms of momentum. So actually, the first mass on this P divided by M will cancel out with the original mass. The second one will remain as a fraction in the denominator. So when we do this substitution, the first thing is this M1 V1I squared is going to become P1I squared divided by M1, right? It's going to look like that. So now we're just going to copy and paste this as a template to all these and do the appropriate substitutions. So it's going to become like this. All right, and now that we're done with our substitutions, I'm going to get rid of this original line. Now, this is really how I should have done it if I didn't want it to be so scuffed, but you know, this is off the cuff, so whatever. And also, part of me just really wants to get through the whole thing, you know, try and get through the whole thing, you know, sort of be a bit of a perfectionist / completionist. So we still have it in our original form. initial momentum equals final momentum, and initial kinetic equals final kinetic. Now, one thing we can try to do is substitution. And I'll be honest, looking at how things have gone so far, maybe it's better if we save trying to do this mathematically for maybe a bit later. But on the other hand, I mean, we'll see how it goes. So first things first, let's try and since we're trying to solve for final momentum, right? Why don't we? Here's the thing, right? We've only got two equations here. They are solvable. We know that they're solvable, but it's like very difficult for me to solve it without some tricks or without physics or without basically cheating using physics. Because, like, let's say I rearrange the first equation, the momentum equation, to be in terms of P1I, and then I substitute that into P1I squared, right? Well, the issue with that is then I have the bottom equation in terms of P2I, P1F, and P2F, which is good because we removed one variable. But then whatever variable we sub in next is just going to reintroduce one of the other variables that we already got rid of. So I really don't know how to solve this like properly algebraically. So unfortunately, we are going to just do the same thing we did last time. But this time, I want to take into account. This one time, I want to be more clear about how many dimensions. So right now, we are considering this as a one-dimensional equation. However, in a second or so, we will be revisiting this equation as a two-dimensional or even potentially multi-dimensional, more than two-dimensional problem. We'll be considering this problem in a greater than two-dimensional case. And here's the thing, I actually don't remember the initial way I figured this out. I thought it had something to do with the dot product. And yeah, there is a dot product, but I thought it involved taking a dot product from the equation, but I couldn't figure out how I did it originally. So this new way does involve dot product, but not quite like that. But then again, maybe it is the original way I figured it out. I honestly can't remember. But we're going to start with the two-dimensional case. And in order to get that working, we need to first change our code so that instead of assigning our ball a random width and height initially in the constructor, we are going to give ourselves some variables that we can play with. So we're going to say double x, double underscore x, double underscore y, double underscores x val, and double underscore y val. Then in here, we are going to just say x equals underscore x, y equals underscore y, x val equals underscore x val, and y val equals underscore y val. And we're just going to pass the parameters straight from the arguments into the variables. And what we're going to do with this here is we're going to actually use these in the ball constructor. So right now we have an empty ball constructor, but now as you can see, that is invalid. We actually want to fill this with arguments. And what I'm going to do is I'm literally just going to copy and paste these lines of code and paste it right in here. And instead of colons, we're going to have commas, and that I think should just work, hopefully. All right. Oh, no comment for the last one. Now there does seem to be some minor issues. Yes. We also don't want these X, Y values, etc., right? We're just plugging things directly in as arguments. So hopefully this just works, and also we'll make everything in line again. Huh. Anyway, so let's press play and we'll see if that works. All right, awesome. Seems to work. And they're not losing energy, they're not sinking through the floor or anything. They are a little too, how you say, they are going through the floor a bit. So let's fix that. So instead of X is, what's the word? Instead of X is less than 0, we should, for the Y at least, we should do X is less than radius. Y is less than height minus radius. Less than width minus radius, and X is less than radius. This should help our collisions work more properly. There we go. Now they are properly no, they are not properly bouncing on the floor because it is going by diameter, because apparently that is the diameter. No, I'm not. What? Why is it doing that? Is it actually bouncing there, or can I just not tell? I feel like it's bouncing way too early. I feel like it's bouncing way too early. Way too early. So I'm going to need to change. Let's change the fill mode in the setup, or the thing. I'm not sure what it is. Circle mode, is that it? Let's take a quick look see. Change mode processing. Ellipse mode. Okay. Okay, but we don't. We are doing circle, not ellipse. So I think we're after circle mode, aren't we? I see. I see. So it also affects circle, presumably. So, in other words, all I need to do is change after size. I need to set ellipse mode. I see. To radius instead of center. And that should do the trick. All right. That did work, but it did reveal that. But it did change our. We do have to decrease our radius down to 20 now. Hooray! Awesome, perfect. That is working pretty well, except for a couple balls that are stuck. But that is honestly, that is to be expected, considering how we changed the code around, which is maybe not the best because it does mean that now balls can spawn on the edge of the screen, which is not the best. I'll be honest, not the best. But for the most part, it seems to work. So, yeah, I'm just gonna have to leave it alone for the time being. And it's kind of funny to watch that ball sort of be stuck on the ceiling. All right. So with that out of the way, what we actually want to do is we want to we actually want to ignore this for the time being, I think. And we just want to have two balls facing each other. So for the time being, we're going to change the number of balls from 10 to 2. And what we're going to do is we're going to have two balls, ball 1 and ball 2. So we're going to say balls 0 equals new ball. We're going to have it at 20, 20, and we're going to move to the right with some random velocity, math.random. We'll keep the random velocities from before. I'm making this way more long-winded than it needs to be, but I don't know what else to do, man. I want to go through all the scenarios, so that's how it is. I'm just getting a little frustrated and annoyed because I've done this so many times before by this point, and no one is really even watching. I mean, one person is ostensibly watching, but wait, is someone watching on Twitch or not? I'm confused. So I don't know if my Twitch is public or not. It's honestly a little confusing. There appears to be someone watching, so I'm just gonna have to take Twitch's word for it. Maybe they're listening to me in the background while they do their dishes or something. In which case, I hope you do well with your dishes. Okay. I'm getting a headache, but I gotta get through this. I gotta keep going. I gotta figure out how to not freeze up under pressure. Okay. I actually have a better idea. No, I don't. Do I? No, it doesn't matter. I'm just gonna copy and paste this code for balls 2, ball 2, which is actually balls 1, and just change the y value by to like 80 or something. Also, these values should be much bigger. So let's actually let's make this a y value of 100, and we'll make this 200 versus 300. How about that? Expecting end of file found that's no good. We need to get rid of the. We need to do that. Alrighty. Now let's save, and we should have two balls heading towards each other. I forgot about gravity. We are not going to be needing gravity for the time being. So in order to get rid of that, we are going to be commenting out these two lines that change the y velocity. After doing that, we should now have right, and we also don't want things moving in the y direction because we're only doing a one-dimensional collision for the time being. We'll do the proper two-dimensional collision right after this, but I just want to sort of just do the one-dimensional collision first, although now I'm thinking this may be more annoying and time-consuming than it is actually helpful in terms of teaching and pedagogy and whatnot. This might actually be not the best, but it is what it is, so go for it. So we actually want to change this to 0. We don't want any y velocity for these two ones just yet. And eventually we're going to have all the balls colliding and it's going to be great. But, you know, we're taking our time with this one. There we go. So we have two balls, random velocities, and currently they are passing right through each other. What we want to do is have them collide with each other. So what we're going to do is take a breather. Take a breather. My head hurts. My head hurts so bad. It makes me want to quit so bad. Like, what am I even doing? I'm stressing myself out so much. I feel like there's so much pressure. I'm not even doing anything really. And yet, I don't understand. What is wrong with me? Why is my brain like this? Why am I so worried? I don't understand. It's been like this for years now. Why? Stop it. I'm laughing, but I'm not really that happy about it. I'm so annoyed. I'm so frustrated, which honestly is an improvement. Considered. I really want to take a break, but alright, let's just take a breather. Give me 10 seconds. Okay, that wasn't me. Oh man. Alright. Alrighty. We're doing it. Alright. Now, what we're going to do is we're going to use our physics knowledge. Sort of. I mean, technically, this is still going to be mathematical, but, you know, we'll say physics inspired algebraic manipulation, we'll say. So, first things first is you know that if the total momentum is conserved and there are only two objects or only two masses that we're considering, that means that any momentum lost by mass 1 has to go to mass 2. In other words, there's going to be some change in momentum of mass 1, right? And that change in momentum, and the difference between momentum final 1 and momentum final 2 is going to be that. So let's do this. Let's show this. So basically the idea is you're going to have P2F minus P1F minus P1I. That is going to be equal to the negative of the difference between the other ones, and that is going to be our delta P. Sorry, delta. Our change in momentum for number 1, right? And we also have a change in momentum for number 2, and this is also known as our impulse. Now here's what we're going to do. We're going to take the top equation, right? And what we're going to do is we're going to subtract P1, we're going to subtract P1I from both sides, and we're going to subtract, wait, no, what are we doing? Hang on, I'm thinking. We're going to subtract P1I and P2F from both sides. So our first equation is going to be P underscore 2I minus P underscore 2F. And our second equation is going to be P underscore 1F minus P underscore 1I. And I have written too many brackets, but it should update now, right? So this is a simple rearrangement. We're just moving 2F from the right side to the left side and 1I from the left side to the right side, right? Next thing I'm going to do is swap the order of these. So I'm going to just put this equation on the left and this one on the right. So now it's P1, right? And notice this is the exact same thing we had before. So this is actually the change in momentum delta P1, right? And notice on the right hand side, we have P2I minus P2F, but that is just the negative of P2F minus P2I. So what we can do is swap that around, place a negative in front, and we can see that that is just equal to the negative of delta P2, right? And all of this is equal to the impulse. And the impulse is just going to be the same as delta P1. So now that we've got all that out of the way, we're going to get rid of the delta P's. And we're just going to leave ourselves with the impulse. Or we can call the impulse delta P for short, if we really want to emphasize that it's the change in momentum, right? Then going back to our original equation, we can plug this in, right? You know what? I'm going to call it I for impulse just to be consistent. So we'll say it's delta P, but we're going to call it I for the purposes of our equation, right? So now we can turn this into two different equations, right? One in terms of P1F and one in terms of, one in terms of P1 and P1F and P1I, the other one in terms of P2F and P2I. And basically it's quite simple. First we can move P1I to the right hand side of the equation. We'll say P1I is equal to, P1F is equal to P1I plus I, or plus the impulse, or plus delta P. You know what? We'll use delta P. Why not? Why not? It does make the latex stuff slightly more complicated, doesn't it? That's all right. And P, on the other hand, we have the negative is true for the other one. So we have to multiply both sides by -1 and then do the same thing. And what we'll get is P underscore 2F is equal to P underscore 1F minus delta P, right? So now we'll get rid of our top equation, and this is now the new set of equations that we will be using. How do we get a bigger space? I don't understand how we get a bigger space. Like what? How do we do that? Like break? I don't know what I just did there, but it's not really what I was after. But it's not what I was after. I think a new line will suffice. So these are our two equations now. And by doing it like this, right? We've replaced our we can replace our now when we do by writing the equations like this, right? Now when we plug in now when we plug in P1F and P2F into the equation, we are only introducing one new variable, not two. So we actually eliminate both variables. Because when we plug in P1F, when we substitute P1F, we only have delta P. And we substitute P2F, we still only have delta P as a new variable. P1I and P1F are already in there. So let's do that. Oh my gosh, this is so long. This is so long. But I gotta go through this. I wish I could make this faster, but no clue, man. I'm just trying to do it off the cuff. So what we'll do is we'll plug these two formulas into our equation at the bottom. One more thing I want to do before we do that is I want to multiply both sides of the bottom equation by m1 and times m2. Just get through it, James. Just get through it. Like every fiber of my being is saying, James, you did this already. Just cut to the chase. But it's like, gotta do it. I gotta do it. I gotta get through it. Otherwise, what else am I doing? Just relax. Just relax. We'll get through this. We'll get through this. Multiply both sides by m1 and m2. So this becomes no longer a fraction. M2 times that, right? Same for this one. And this 2, except this gets m1, and this also gets m1. Perfect. Awesome. And technically, sorry, I was just thinking, I know I froze up there, but I was just thinking that technically, yes, this delta P is actually delta P1 because it's the change in momentum 1. My gosh. How does this work? Where's the second one? Oh, there it is. Alrighty. Now, the next thing we can do is substitute these equations into the bottom, right? Yes. Okay. So let's do that. So 1F will become 1I plus delta P1. So let's make that substitution. And we'll do the same thing for this one as well. Now that we've done those substitutions, we can actually get rid of our first two equations here. So we'll do that. Sorry, I'm freezing up a bit. Maybe I should take a break. Okay. Now, we need to expand out these squares with the sum of squares and difference of squares formulas. So it shouldn't be too hard, but it just means that, this is going to go from something squared, something plus something all squared, to something squared plus 2 something something plus something squared. So our first one, P1I, so let's just get ourselves a new line. And let's expand the right-hand side. So let's get rid of the right hands. So let's expand out the right-hand side. So M2P1I, right? Let's change this to our big curly brackets. It's going to be P1I squared plus 2P1I. All right, I'm going to change to I now. I'm going to change to I. Delta is just too much. It's going to be minus I and plus I. It just overcomplicates it. Sorry, I'm just lost in thought. I am lost in thought at the moment. I'm getting tired. I know I'm going around in circles. I'm thinking about how I can make this more succinct. If I plan this out better, how would it look? How would it be if I edited it better? You know, if it wasn't a live stream. So my mind is just a little occupied. Sorry about that, but I'll try to get. Yeah. Plus 2pi plus I squared. And it's going to be the same thing for the second one, basically. Oh, and also this is no longer squared at the end. So that's one. And then the second one is going to be basically the same, except instead of 1i, it's going to be 2i. And very importantly, this second term is going to be negative because of the difference of squares formula. So now that we have all that, this is our new equation. And the next thing we're going to do is distribute, same thing. We're going to distribute the M1 and M2 terms. So M2 is going to be distributed here, here, and here. And M1 is going to be distributed here, here, and here. And let me just double check that I did that all right. Yeah, I'd rather put M2 in here though. All right, now, as you can maybe see, we have some common terms that we can cancel out. So what we can do is get rid of M2 P1I squared and M1 P2I squared because we have a copy of those on both sides of the equation. So let's do that. Let's get rid of them. So the left side is going to become 0, and the right side is going to get rid of this term and is also going to get rid of this term. Now we are almost done. Almost done. Next, what we have to do is actually factor out I from the right side. So let's do that. So we're going to say 0 equals I times 2m1 p1i plus m2i minus 2m1 I'm a bit confused. I feel like I've made a mistake somewhere. Give me a second. Oh, I don't have. All right. I just need to figure something out. That should be M2P2I, shouldn't it? Yeah, it should. It should be. That's all right. That's all right. I wonder why all the monsters come out and know. Maybe I can see it on the stream. I don't know. Oh, I'm lost track of the equation. I actually did it better yesterday. What are the odds? What are the freaking odds, man? Okay. I substitute. Let me think about this. I substituted it's P1F, it's P1I plus I squared, right? And then P2I plus I squared. And it's going to be M1 oh my gosh. I'm distributing out. Maybe I can figure it out. I'll watch it on YouTube. It's a bit silly, but I think I might be able to figure this out. I'm going to go back. All right, I need to mute myself. I'll figure this out. I'll figure this out. I'll figure this out. 65 minutes ago. This is the worst. This is even longer than last time. Oh, well. Before I had it distributed. It was M2 for P1I and M1 for what should be P2I. That should be P2I, but I miswrote it as P1I. Okay. So this is I screwed up here. It should be M2. This should be M2. This should be M1 P2I, and this should be M1I squared. Okay, got it. Now that that's out of the way, let's write the equation proper. So we're going to factor I out of it. So after we factor out I, we'll get 2m2 p1i plus m2 I minus 2m1 p underscore 2i plus m1i, right? Which means that either I equals 0 or how you do an up, like, you know, like an or symbol. I don't know how to do it. Yeah, this one, wedge. So either I equals 0 or the following, or I equals, or this equation here is 0. And if we solve that for I, we will get oh, I see. Huh. Interesting. So either I equals 0 or 0 equals 2m2 p1 1i plus m2 I really need to redo this, I think. I don't know if I'm going to do a part 5 or not, but we're just going to have to... I might split this into another part for a part 5. Just want to do the equation. Is it so hard? M2 P1I There we go. Minus 2 do this properly. M1 P2I plus I M1 plus M2, right? Now, what we can do is take away both sides of this. We can move this to the other side, which gives us this, except it's now the numbers swapped. And lastly, we can divide both sides by M1, M2. And we can get the following. And there we have it, the final equation. Now what I want to do is make the two balls run this code or run this equation when they bump into each other, right? Basically, we want to calculate the momentum, add this to the momentum, divide by the mass. Or, in other words, this is the change in momentum. We know P1, we know P1F equals P1I equals P1I plus I, right? So in order to get the velocity, we need to divide both sides of this by mass 1, right? So then V1F is going to be equal to V1I plus I divided by mass 1, right? And same for velocity 2. These are our final equations. Okay. This sucks. I'm so inefficient. But yeah, it could be made a lot quicker, I guess, if I did like a short or something. I'm not sure. Also, if we assume the masses are 1 and 1, that also simplifies the equation, because then it just becomes mass 2 mass 1, momentum 2 minus mass 2, momentum 1, you know? Honestly, it's hard for me to concentrate because I'm thinking about how I could do this as like a short or something, which is kind of funny. But yeah, oh my gosh. I can't do that. That'll get me fucking striked. Oh my gosh, I'm not ready for this. I'm not doing well, but I'm losing my fucking marbles here. I slept a whole. I could have done this yesterday, but I decided, oh, I'll do it later. And then I waited a whole freaking day, and I got to 9 o'clock, and I still didn't do it. And so I ended up streaming at like 11 or like 11:30. Terrible. I don't know what I'm doing. I'm doing my best. I'm doing my best here. Just give me a second, man. Shh. All right, so stream part 4 is going to be exactly the same as part 3, but you know what? It doesn't matter. All right, hang on a second. Let me mute everything. Jesus. All right, and we're back. Got interrupted. I don't know how to feel about it. I should take it better, but it's hard. I think we're gonna have to do it another time. I'm not in a good headspace. We're almost done. I need to do this equation again for the multi-dimensional part. Hmm. I'm 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 out of it. This is a terrible stream. This is terrible. I might even decide to redo this again. I don't even know, man. Can you believe I've been doing this for an hour and 20 minutes and I've still gotten almost nowhere? How does that happen? How does that work? Mm, mm, almost makes me think I don't have it in me. This is why I didn't do it last time, because I would do the fucking Mega Man videos and other things I want to record, and I would just be so stressed out and I wouldn't do anything. Every fiber in my being is telling me to end the stream, and I have to try and not, because I have to try and get through this, but I don't know what to do. So I'm not doing the right thing. I don't know what the right thing to do is. It's so hard. It almost makes me like, should I just be doing my own projects and not trying to make streams of them? But then if I don't make streams of them or anything, like, what am I doing? Maybe we come back to it another time. I don't know. I think we have to get through it. But can I really be bothered to code? Like, I'm just so stressed right now. It's so bad. We want to add a collision function, right? And basically, we want every ball to collide with every other ball. And we want to do this. But we also want to do this in 2 dimensions. And all right, I think I'm going to try again. I think I'm going to take a break, come back. We'll try and do it maybe in the morning or something. I'm not sure. I'm going to try and run through this whole logic one more time. I think we can consider this this stream and the last 2 streams, or at least this stream and the last stream, practice rounds. This is the first one, so you know, this is the first project, so it's perhaps somewhat understandable that I'm not getting it quite bang on the first time. Now, as for how I'm supposed to do it, my gosh, who knows? But oh my god, oh my god, what am I doing? What am I doing? Why can't I just explain maths properly? Have I still got brain fog? Like, what's going on? I thought I was doing fine last time. Is it because I don't want to be doing this project anymore? Because I want to move on to a different one? Is that it? Am I getting bored? Do I have ADHD? What's wrong? Why can't I focus? What is wrong? I should ask the doctor, maybe. I'm not sure, but I don't see him for like another couple weeks, so it doesn't matter anyway. I don't fucking know. I don't fucking know, man. What am I doing? 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 There's so much to do. There's so much. I'm overwhelmed. I've given myself, somehow, even with the very limited amount of projects I've given myself, I'm already fucking overwhelmed. How does that work? I'm sorry for swearing. I don't hope this doesn't get marked as like explicit, too explicit or something. That would suck. My gosh. What am I doing? What am I doing? I can't even think straight. I can't even think straight. What am I doing? Okay, here's the deal. I know it's a bit annoying and it's repetitive, but for part 5, I think I'm going to just try and do this again. But I'm going to try and do it again properly. I'm going to try and do it quickly. I'm going to start with the momentum and kinetic energy, and I'm going to very quickly go through the motions of getting to this equation here. This is the goal, this equation here. Then I'm going to do it. Then we're going to code it up. Then we're going to do 2 dimensions and so on and so forth. And if we want to end up with my code looking the same as the original one, that's what we're after, okay? But this took way too long. Like, this is just over the top. Like, what is even going on here? It's very, it's fine. It's fine. It's fine. It's fine. It's my first time. I knew it wasn't going to be that good my first time. I thought I could mitigate some of that worry by doing the streaming. I didn't consider the fact that I could be going around in circles on a stream and on a stream, and since it's a live stream, I can't cut any of that out, so it's just going to be very long-winded. It's okay. It's okay. It's okay. It's okay. It's stressful. It's okay. It's okay. We're learning. I think I'm going to call it quits here. I do need a break. Like, seriously, I am coming at the edge of my limit. I think I'm going to take a break. I'll come back for part 5. We'll do this again. I'm so sorry. It's a waste of. I know. I'm sorry for wasting your time. I know there's only one person watching, and I don't think there's even necessarily a person. It could be a bot or something. Who knows? Apparently, I have a viewer. I don't know who it is, but so yeah, I'm just gonna like end the stream, and I'll try and come back tomorrow. If I don't do it like in the morning, I'll try and hit like 4 p.m. Australian time, 3 to 4 p.m. Australian time, maybe 5, maybe 7, 3, 4, 5, 6, 7. Those I'll give you. I'll try and start again tomorrow. I'll try and do it properly. Try and get some sleep. Try and do this properly. Try and not be so stressed out. This was, yeah. Although not as stressed as I was during the Slime Rancher thing, for some reason, I actually remember being quite stressed during that, even though I was just playing a game. Who freaking knows? Anyway, this is terrible. Maybe I should have prepared something, but oh well, we'll figure it out. Oh well. Okay, anyway, oopsie. Sorry about that. Sorry, guys. Man, that sucks. Oh man. Oh man. Oh man. Na, 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 na. Na, 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 na. Well, whoever my one viewer on Twitch is, thank you for whatever the heck happened that made you watch this. Because Jesus Christ, this is low quality at the moment. Oh, I'm on just chatting. Why am I on just chatting? Oh, I'm not supposed to be on just chatting. I'm supposed to be on freaking Oh, I would have been on just chatting last time too. Oh, I'm supposed to be on freaking uh I'm not trying to clip anything. How do I change this? Software and game development. No wonder, no wonder, no wonder. Okay, there we go. And on YouTube, what category am I on YouTube? But what category? What category is it? What category? How do I get to the streaming thing? Your channel. That's not right. Your channel. YouTube Studio. Maybe there's something for streaming. Uh, uh, oh, hang on. Content, live, this one, streaming software, yes, edit, category. It should be education. Yeah, that's fine. These should also be category education. All right. Why am I still streaming this? Who knows? Who knows? Why is one person watching me even though I was on just chatting? Who knows? Who knows? Why are they still watching me? Who knows? I have no clue what in the world is going on. Look at all this fancy stuff. Wow. This is longer than last time. How is it longer than last time? It doesn't make any sense. Oh, last time I split it into two parts by accident, so I'm actually going to have to go and redo those two videos too. So, you know what? It doesn't even matter, because technically I guess this is part 5. Crap. Who knows? So it would be part 2, part 3. Terrible. Terrible. You know what? It's fine. It's fine. It's fine. I will try again tomorrow, and I'll try to do it properly. All right. Mamma mia, mamma mia. All right. That's going to be it for today. I'm so sorry, guys. I'll try again tomorrow. We'll try and get it done. All right. Thank you. Sorry about all that. Have a good day. See ya.